Hello, in this video we are going to see simulation of monetary policy when price level is constant. In the short run we have the first effect that happens when price level is constant, and then the first effect is that the LM curve shifts from here to here. And as a consequence of this parallel shift, then the equilibrium passes from here to here. This is the first effect. And then there is a second effect that takes place when price level increases, and then the LM curve shifts from this blue line here to this pink line here. And then the equilibrium passes from this point to this point. This is the second effect. In this video we are going to see the first effect that happens when price level is constant, and this is the assumption used in chapter 5 of the book that we are trying to follow. So in this video we are going to see this first effect. In this video we are going to see only simulation. Then in next videos we are going to see the intuition, and after that we are going to see the second effect that takes place when price level increases. So now we are going to use simulation to go from here to here, the first effect. Okay, let's get started. If these are the initial data, then the graphs that we get are these. If this is not clear to you, it might be convenient to see the previous videos. Okay, we are going to see monetary policy, so we are going to modify M in the money market. So we are going to increase nominal money supply from 600 to 800, and then we can see two effects. The first effect that we mentioned before, and the second effect, which is this pink point here. And then this information propagates on the rest of the graph, but we are not going to see the pink part, which corresponds to the second effect. We are going to see, as we said, only the first part now, that goes from here to here. But we want to understand the relationship between this graph and the causality. So in order to do that, we are going to start from scratch, and now we are going to go step by step. So we are going to do the same. We increase money supply, nominal money supply, from 600 to 800, and then we are going to see step by step what happened. So before increasing the nominal money supply, we have that real money supply was 600 divided by 2, 300, and real money demand was this. And then if interest rate is 0, then I am here in the horizontal axis, and then in this case income takes the value 300, so that's why the LM curve starts in this intercept 300. Now if we increase M from 600 to 800, then here the real money supply is 800 divided by 2, which is 400, so income will be 400, and then the new intercept is going to be 400. So this is a parallel shift of the LM curve from 300 to 400. So this is what we will get here. Okay, now as a consequence of this parallel shift, the equilibrium will pass from this point to this point. So we get this point. If you want to understand why we get this number 450 and 2.5, then you can see the video entitled Intersection between the IS curve and the LM curve. But if you stay with me like 10 minutes or so, then we are going to see how you get this equilibrium. Now we are going to use this information and we are going to go to this graph, the money market. In the money market, we have real money supply, which is this red line, and real money demand or liquidity, or L, that it is this blue line. So before we increase M, we have this red line that was 300. Now we increase M from 600 to 800, so the real money supply will be 800 divided by 2, 400, so there is a parallel shift of real money supply from 300 to 400. So this explains this new red line here. Now we have to explain why real money demand, which is the blue line, shift from here to here. This is the real money demand. So when we get this point, then income in equilibrium is 450. So we use this information here. So when interest rate is 0, then L takes the value 450, and then this intercept is 450. So the blue line shifts from 400 to 450. So here we should see these two effects, the parallel shift of real money supply and the parallel shift of the real money demand. And the new intersection, and in the new intersection the interest rate is 2.5, which is exactly this 2.5. We have seen that before. This happened because in order to get this equilibrium, we need the equilibrium in the good market, which is the IS curve, and we need equilibrium in the money market, which is the LM curve. So as we come from the equilibrium in the money market, then here the interest rate has to be 2.5, because in this point the real money supply, which is the new red vertical line, has to be equal to the real money demand, which is the new blue line here. Okay, so now we are going to transfer this information, this interest rate, in the investment curve. So when the interest rate was 5, then the investment was 100 minus 50, and we got 50 here. Now the interest rate went from 5 to 2.5, so now we have 100 minus 25 and we get 75. So the investment should go from 50 to 75, which is intuitive because the lower the interest rate is, the higher the investment is. And now we go to the exchange rate graph. So before making the math for the new interest rate, let's remember what happened when the interest rate was 5, how we got this 10.1. The foreign exchange market is in equilibrium when investing here in the local place is equal to investment going through the foreign country. So this will be the money that I get in 1 year if I invest locally, and this is the money that I will get in 1 year if I go like this through the foreign country. So the exchange rate in equilibrium has this expression that we have seen in previous videos. So if we see in the exchange market panel, we see that the interest rate abroad is 3% and the expected exchange rate is 10.3. In this case, local mean Argentina, abroad mean United States. And we have interest rate, which is 5%, and this is an endogenous variable and this is exogenous variable. This is endogenous because it is produced or determined within the model. How it is produced within the model or by the model? Well, it is the intersection between the AS and the LM curve, where these two variables are outside the model and we can change them as we please. But as we mentioned before, this phi, this interest rate, is expressed as a percentage, and this interest rate abroad is expressed as a percentage. And here we need it in the conventional way. So the first thing that we do to get the interest rate in USA is to take the interest abroad expressed as a percentage and divide it by 100. Then we get 3%. 3 divided by 100 is 0.03, which is this value. We do the same to get the interest rate in Argentina. It is the interest rate expressed as a percentage, which is 5 divided by 100. So the interest rate in Argentina is 0.05, which is this value. And finally, the expected exchange rate, the rate that Argentinians expect in 1 year from now, is 10.03. So if you calculate this expression, then you will get that the exchange rate is this, that rounded is this value. So when interest rate is 5, then the exchange rate is 10.1 approximately. Now what happened in Argentina when the interest rate goes from 5 to 2.5? Well, intuitively, just watching the graph, we can see that when this, we have seen this in previous video, when interest rate goes down, then it should hit this curve about here, and then the exchange rate should go up. So in this expression, the exogenous variable will not change, but this, the endogenous variable, will go from 5% to 2.5%. So let's see this effect. Then when interest rate goes down, the exchange rate goes up. Now let's understand why it passes from 10.1 to 10.35. These values don't change because they are exogenous, but this interest rate in Argentina vary because this is an endogenous variable. So interest rate in Argentina goes from 5% to 2.5%. So if we take this information in percentile and we divide it by 100, then we get 0.025. So if we plug in this value here, then we do the math and then we get this, that rounded is 10.35. And we have seen the intuition of this in the video entitled The Foreign Exchange Market. Okay, so now we will go from here to the goods and services market. So let's do that. When the interest rate in equilibrium was 5, then the intercept was 200, which is this 200 here. Now the interest rate go from 5 to 2.5, so here we have 2.5. Then here we have 10 times this is minus 25, then this minus this is this, so the new intercept is going to be 225, so there will be a parallel shift of the aggregate expenditure curve. So this is what we get here, and as a consequence the income, which is equal to aggregate expenditure, because the goods and services market is an equilibrium, is 450. It is not a coincidence that this is 450 and this is also 450. Why so? Because here it is clear that the goods and services market is an equilibrium because income is equal to aggregate expenditure, and it is bound to be this way because this information comes from this intersection, and in this intersection both the goods and services market represented by the AS curve is in equilibrium, and the money market represented by the LM curve is in equilibrium as well. So this value has to be 2.5 because we come from the money market in equilibrium, and this point has to be 450 because we come from the good market in equilibrium, which is the AS curve. So we can see again that we are not able to draw this line until we get the interest rate in equilibrium. So first we have to get the intersection between these two curves, and second we can draw this line. And finally, let's show what happened for the aggregate demand curve. So how we got the intersection between the IS and the LM curve? Well, for any value of income, these interest rates are not necessarily equal. For example, here the interest rate for the IS curve is 0 and for the LM is not 0. But if we want the interest rate in equilibrium, this happens when both curves take the same value. So in order to find this income in equilibrium, we have to say that interest rate for the AS curve is equal to interest rate for the LM curve, and then we will find this point. So this is what we do here. The interest rate for the LM curve is going to be equal to the interest rate for the IS curve. So if we do that, then we get only one variable, which is income, and this income that we get is the income in equilibrium, the income for which both interest rates are the same. And if you plug in all of these values here with M taking the value 600, the original value, then you will get an income in equilibrium which is 400. Now if you go from 600 to 800, then the math will give you a new income in equilibrium, which is this 450. But the other relevant thing is that the value for P, for price level that you use, is this, is the initial value, which is 2. So here this P has to be 2, and then you get that for P equal 2, you get income in equilibrium equal to initially 400. So you get this point for price level 2, then you get income 400, which is this point. So this Y in equilibrium is this point here for P equal 2. But we don't want to have only one point of this curve. We want the whole curve. So what do we do to get that? Well, we have seen that in previous video. We drop the assumption that P is constant, and then we vary P, we take it as a variable, and then income will not be constant anymore, so income is going to vary too. So when P is constant, then you get only one value for income, but if P now is free, then it moves along the vertical axis, so income will be variable along the horizontal axis. So you just use the same, exactly the same expression as before, but with P variable and with income variable, and then you get this curve, which is this curve. Now what happens when you use fiscal policy increasing government expenditure, or for example monetary policy changing M? Well, in both cases something similar happened, but not exactly the same. If you increase government expenditure, then you pass from G to G plus an increment in G. We are going to see this when we increase G0 here. And then in this case, I'm going to show that in the separate video later, but the intuitive idea is that if you do the math here, what you get if you increase government expenditure is a constant term here. So you get exactly the same expression that you have initially, but you have a constant term here when you increase government expenditure. Oops, this is in Spanish, well, but it is very understandable. Constant term, which is this, and this is constant because you can get it from this panel. So why this is a total parallel shift? Because you choose any value for P, and then you get that the income for this P is exactly the value that we have before the fiscal policy, plus this constant term. So for any P, Y goes from here to here. You take another P, and then it goes from here to exactly the same increment. Now, what happens if we use monetary policy? That it is what we are using now. Well, in this case, the shift is not exactly parallel. So if M is incremented by this, then the shift is not parallel, because if here instead of M you have M plus this, then the term that you are going to get here is this. I can show you in separate video maybe, but it's quite straightforward if you do the math. But the important thing here is that this term doesn't depend on Y and doesn't depend on P, so it's constant, where here this term does depend on P. And that's why in the case of monetary policy the shift is not parallel. So let's see this with a little bit more of detail. So when you use fiscal policy, you increase government expenditure, this term is constant, so you have a parallel shift. But if you use monetary policy, then you go from this expression, you are going to go to this expression. Instead of M, you have M plus this. Therefore, you have the same thing that you have before, plus this term that does depend on P. What does it mean? That as P increases, because you have a division here, as P increases, then this term is smaller. So you can see this effect here. As P goes from 2 to 3, this P increases, then this value gets smaller. So you can see here that it gets smaller. Where in the case of fiscal policy, the shift is totally parallel, because this is constant. So as we are using monetary policy, then the shift is not going to be parallel, like in this case. It is going to be like this, not exactly parallel shift. So let's see it. Then why it looks like kind of parallel? Because here we use in this example increment of m of 600, quite big, to see this effect, whereas in our example we passed from 600 to 800, so the increment was just 200, and here we have 3 times more. So that's why you don't see by the naked eye that the shift is not parallel. But if we do the same using this increase, then you will see the effect. So the conclusion is that there will be a shift of the aggregate demand, and then income will pass from 400 to 550. So this is the effect of expansionary monetary policy when we increase M from 600 to 800. But we have to take into account that we are assuming that the price level didn't change. In the next video we are going to see the intuition why the equilibrium passed from this point to this point when we increase nominal money supply. So in the next videos we are going to see the intuition of this first effect, and then after that we are going to see the second effect. Okay, thanks for watching and see you in the next video.